Hello everyone, welcome back to our channel. So today we are going to discuss another problem from the CSES problem set. So without wasting much of it, let's jump into the problem statement. So the problem statement is saying you are given with a string of length n and you need to find the number of distinct substrings of that particular length, and length goes from 1 to n. Okay, and the given input is AB and okay. So let's understand what the problem statement is saying. So the problem statement is saying we are given with a string AB and we need to print the count of all of the substrings of length varying going from 1, 2, 3 and 4. Okay, so if we talk about the total unique substrings for length 1 is A and B, so these are the only possible. So 2 for 2 length substring, if we count all of the 2 length it would be AB, BA. These only 2 would be possible because this AB would again be a duplicate, so 2. Same goes for 3, so it is ABA and BAB, so same goes for 3 as well, so 2. And for 4 it would be single substring only because we are taking the complete string. So this is what we actually need to output. Now by reading the problem statement, we are thinking that this is a very easy problem because if we go by the brute force method, for every string of length n, we would find for each and every k, where k is the length of the substring we talk about, length of the substring I'm considering, length of the substring, and we'll calculate the substring using s dot sub str and use some kind of a hash set or a set to get the count of all of the substrings. But here n goes till 10 raised to power 5 in the question. If we can see from the question that n is going to 10 raised to power 5, and in our this brute force method we would actually land up to a complexity of big O of n cube, because the s dot sub str also takes time of big O of k. So like in worst case it would land up to big O of n cube. So that won't be an acceptable solution, or if we talk about big of n square as well, that won't also be an acceptable solution. So we are able to understand that we need to like optimize this. We need to optimize this either to big of n or something big of n log n, like in some sort of this fashion. But now the question arises is, how do we actually optimize this? Because the thing is, we need to calculate all of the substrings, right? We need to calculate all substrings, and we don't know any, we have not yet read any kind of optimizations that how do we actually calculate all of the substring in a easy fashion, I would say. Okay, so now let's divide this a big chunk of problem into small steps, and let's see how we can actually optimize each of the following steps, and then with that we'll see that we can actually optimize the complete problem. Okay, so if we see, let's understand what our pane area is. If we talk about the pane area, so our pane area is actually calculating the substring multiple times, because if we see, let's suppose we take the string as ABAB. The total possible substrings of length 1 is 2, which is A and B, but we are actually calculating it multiple times as in, first we are going to check for this A, then we are checking for B, then we are again checking for this A and this B. So these are actually the wasted operations I'm doing. Same goes for AB as well, of length 2. AB I've calculated, B I've calculated, but the same I'm calculating this AB. So if we talk about an n length string, so we would be doing a lot of redundant operations. So we need to optimize this particular pane area, then we'll optimally like reduce the time complexity. Okay, so now let's see how do we actually do that. Okay, so let's understand. So this was actually the step 1 of, like, I would say understanding the problem, what was actually our pain area is. Now let's discuss how our second step would be. Now second step would be actually analyzing of how do we we should approach this problem. Okay, so let's suppose we consider a string. Let's suppose we consider a string as banana. Okay, now if we observe a very small thing as in that every substring is just a prefix of suffix. If I write this particular line, are we able to get anything, or like are we able to understand what do we actually mean by this? Okay, so the line is saying every substring is just a prefix of a suffix. This might seem a bit confusing, but let me explain you. Now let me consider this particular string banana. Now let's write all of the suffixes of this particular string. So if we talk about suffixes, banana, ana, na, na, and a. These would all of the suffixes possible, right? Now if we talk about this and we read, just keep in mind this particular statement that I have written, every substring is just a prefix of suffix. Okay, now if we talk about, now we'll calculate the prefixes. Now we go and see the prefixes. Now if we go and see the prefixes of a, n and a, so what are the prefixes of a and a? It would be a, an and ana, right? And same if we go for let's suppose we same and go calculate it for a, n, ana, banana. It would be a, an, ana, and so on and so forth, right? So can we say these all are the substrings of a given string that we're actually talking about of different lengths, right? So isn't that, if I say that if I know all of the suffixes and if I go and deal with all of the prefixes of that suffixes, I would actually land up getting all of the substrings, right? But here is the problem in it. If we see, the problem in it is actually dealing with duplicates, like because a and a also have a substring of a, an and ana, and same for banana as well. We are actually calculating it twice. Now the thing is, we need to optimize, or we need to remove these possible substrings that we are actually considering twice. Okay, now let's see how do we actually do this. I hope you have understood till here that what I'm actually talking about, like on what lines we would be approaching this problem. Okay, now let's jump to step 3. Now here we would be using a very great algorithm which is actually used mostly in strings, which is some kind of a suffix array and LCP. You must have read about this, which is the longest common prefix, okay. Now let's understand what do we mean by a suffix array and a longest common prefix. Okay, so suffix array, by the term only, it is true that we are talking about this particular suffix array that we have made here. So this kind of considering all of the suffixes is our suffix array. Now what I'm saying is, I would be sorting this suffix array, right? Now let's say we consider an example of AB, ABA. Okay, let's consider this particular example. Now let's make the suffix array a sorted suffix array. So it would be A, which would be starting at index 4. Now next would be ABA starting at index 2. Then it would be ABA starting at index 0. Then it would be BA starting at index 3. Then it would be BA starting at index 1. So this is a sorted suffix array for this particular string, right? Now let's understand what do we mean by LCP, the longest common prefix of a suffix array. Let's understand what do we mean by a longest common prefix. Okay, so if we draw the suffix array of this, so suffix array would something be like 4, 2, 0, 3, 1. So it would be telling us the indexes from where my suffix array would start. Now if I talk about LCP, if I say LCP of I, it would be the length of the longest common prefix between SA of I and SA of I minus 1. Okay, now let's see in the problem as well. Now if I talk about this particular SAI and this particular SAI, okay, now I know that A and A here is common, right? So I know that longest common prefix between these two would be A, like of length 1. Okay, if I talk about this ABA and this particular ABA, then I know the longest common prefix between them is 3, which is ABA, right? The main reason of sorting the suffix arrays due to this only, to calculate the LCPs, right? Because with this only I would be able to know that if I'm dealing with a particular string, if I'm dealing with a particular suffix array, then these particular duplicate suffix arrays, or the suffixes or the prefixes which I'm considering would already be considered in this particular substring, and I would have to calculate the unique substrings that are left, which we'll be seeing in the further steps. Okay, now if I draw the LCP also, LCP of A, like A and ABA would be 1. Similar, if I go with ABA and ABA, it would be 3. ABA and BA, it would be 0. And similar, if I go with BA and BA, it would simply be 2. So our LCP array would something look like this, right? We will not be in this video will not be getting much into implementation of how do we optimally calculate LCP. So for that you could read the algorithm as CSES algorithm. Let me write it again. Yeah. For that you can read the CSES algorithm. With this you can calculate this whole of the thing in big of n log n. Like I would be showing you the in the code as well how I've written the suffix array and the prefix LCP as well. I will be sharing the code as well, so you will be able to see there also, but you can, for now you can read the CSES algorithm to calculate LCPs optimally, right? Now we have actually known what is the suffix array, what is the LCP. Now the question arises is, how do we actually calculate the total number of substrings? Okay, now let's move to the next step. Okay, now let's understand how do we actually calculate all of the possible substrings. Now if I consider a particular suffix array, so if I talk about this, then I'm actually talking about the suffix possible, like the string I'm talking about. So SA of 0 was actually 4, so it's 4 till end. It would be, I'm talking about the last substring, right? I'm talking about the last substring that I'm talking about. So last substring is this. So if I talk about all of the possible substrings, if I dealing with this particular suffix array, can I write it would simply be n minus SA of 0. So it would be simply 1, right? Now if I talk about this SA of 1 till end, SA of 1 is 2, So all of the possible substrings, so I'm talking about this particular string, so all of the possible prefixes are a, ab and aba. So it would simply be n minus sa of 1, which is equals to 5 minus 2 equal to 3. But now here is a catch. Here is a catch. The catch is actually that this particular a has already been considered here, which I have already taken as 1, right? So I'm considering this a as twice. So now what I would have done is, now I have just recall that we have calculated the LCP also, right? What LCP of 1 says us? LCP of 1 says us that there is a one length common prefix, prefix between a and aba. If there is a common prefix between this, so I need to actually remove that, because when I would have calculated for a, I have already considered this one length prefix, but when I am calculating for aba, I need to remove this, right? So what our net answer would be? It would be something like SA of 1 minus LCP of 1. So it would simply be 5 minus 2 minus 1, which would else be 2. So if we talk about all of the possible prefixes, it would be AB and ABA. Right, I hope you are getting the logic what I'm talking about here. So if we generalize this for any ith, it would simply be n minus SA of I minus LCP of I. So and adding all of this would give all substrings. So in this way we have actually came to a solution that how do we actually calculate all of the substrings in a very optimal fashion. Here the time complexity will be big of n log n plus big of n to calculate this particular thing, big of n. So this would be net complexity. But now if we see the problem, in the problem we see that we need to output like the distinct substring on the basis of the length. But here we have not talked anything about the length over here right now. In this we have just calculated all of the possible substring. So like if I talk about in this video, we have actually dealt with two different problems. Like I have given you the approach to solve the problem in two different fashions. Okay. Now if we go and see the final step of how do we actually calculate it for the length as well. Okay. Let's move to the final step. This would be how do we actually now go and find this for the all of the possible lengths. Okay, so now let's consider a suffix a, b and a. Okay, now if I write and give you some of the things, now can I say that the possible prefix length would be till 1, 2 and 3, right? This I know. And also if I know this particular thing, and also I know that LCP with previous suffix was 1. This means there is one duplicate, right? Now can I say that if that in the range, can I say in the range of LCP of 1 plus 1 till n minus SA of 1, all of the lengths between this range would all be unique, Can I say that? Would all be unique. I can say that because if we talk about a particular string ABA, what are the possible prefixes? It would be A, AB and ABA, right? And if we talk about the indexes, so it would be 0, 1 and 2, let's suppose. So now here my range was from between 0 to 2, but what I'm saying is I've already have a one length kind of common prefix. So wouldn't that my range would actually be length from length of 1 to 2? Like if they're talking about the length, okay, I'm here talking about the length. So length here would be till 1, like I would be going from A, B, and there would be 2, which is A, B and A. I would not be taking this particular A, right? So in this way I would be knowing for each of the string, I would be knowing their L to R, right? Like from this particular this minimum length to this minimum length, there would be a substring, right? There would be substrings, right? And now to calculate all of this, we have done this many of times. This is now simply a range update problem, where you know the range between L to R, and you would be simply doing L minus minus for the range and R plus plus for the another range, and then you will be adding this up, and you will get for each length you will get the range, like the count. Okay, so this is how you would be then counting for each of the lengths as well, that how many substrings are possible. So this is how our net problem would be solved. I hope you have liked the solution, because in this was actually a very in-depth solution we have talked about, considering all of the cases and explaining you well. And I'll show you the code as well. So this is the code that I have written. Here I have made the suffix structure where index and rank has been stored. You can refer to this code as well. I will add this particular code in the description of the video. You'll go and see the code, and if you have any issues facing the code, just let me know in the comment section. I would be explaining you, I would be like clarifying your doubts over there as well. Okay, thank you everyone. I'll hope you will see you in the next video as well. And in like agenda of this is in the next video I would be covering more of the string algorithms to help you better and grow more in the DSS stuff. Okay, thank you.